follow up on that diving video by doing the science behind heat capacity. This is a painting that my son Mark did a couple of years ago. Beautiful view. Some of you recognize it as Little Traverse Bay. Northern Michigan is just a great place to live in with all of our lakes. And that is the view right there, as taken in by my other son, Cooper. Two of us took in sunset. Wonderful view in the summer in Northern Michigan. So many reasons to love living up here. The jokes are one reason I think to live up here. So, this is a classic. Ah, get it? Instead of a seagull, a bagel? Yeah, no escaping the jokes. So with regards to our lab, here is our learning target. We're going to look at large bodies of water. Why do they have a moderating effect on our local climate? So right now what I need you to do is go back into Google Classroom, find this PDF file, and you can either make this graph for today's lab in Kami, or you can print it and handwrite the 3-line graphs that I'm asking you to do. We're going to take a look at the change in temperature in air, land, and water as we heat it up and cool it down. The red numbers are for heating, the blue for cooling. But your graph looks just like this. And my lab video will start off at minute 0, and I'm measuring the air, land, and water temperature at room temperature. And oddly enough, air for some reason is a little warmer. But I need you to use some semblance of a key. I'm using a little poof for a cloud, a dot for water, and a square for land. And if you would please make a dot for each of those 3.
We're going to get this lab
as
started.
We start
our first data
lab.
point is time
Enjoy.
0 right there. And at time 0, what I'd like you to do is put a data point for air at 20 degrees Celsius. And for land, we're coming in at 17 degrees Celsius. And water is exactly the same, 17 degrees Celsius. I know it seems a little bit strange. You would think all 3 of them should be exactly the same, room temperature, but you know, the thermometers aren't exactly consistent. You know, we're doing the best we can. So I'm going to turn on my heat sources here. We're going to start our timer. That's my iPad out of the camera's range. 2 and 3, our heat sources represent the sun heating up air, soil, and water. Here we go. So every minute we're going to record the temperature of each of these 3 substances on our graph. And every time we go a minute, what I would do is I'd pause the video, get the temperature readings plotted out on your graph, and then continue playing the video. I gave a lot of thought as far as, you know, what am I going to do in between data points? Because, you know, a minute is a long time. So I hope you're okay if during the lab I share with you some rib-tickling riddles. And I also have the biggest riddle book in the world. So, you know, there's always something to do. But we are closing in on our first minute of heating. I'm going to stop narrating and start giving data. So here we are. At 1 minute, we have air at 30 degrees. Put my little cloud there at 30. And the thermometer reads for land 22 degrees. Make sure you put this under minute 1. 22 degrees for land. And water is at 19 degrees. So we already are seeing the 3 substances just after 1 minute start to change their course. All right. What do we got here for our rib ticklers here? Do you know why the carpenter quit his job? He was bored. Hey, it's already minute 2. here we go, folks. Minute 2, we have air coming up at 46 degrees. Put my little cloud on minute 2, 46 degrees. My soil is reading 27 degrees. 27 degrees for soil. And my water is 21 degrees. 21 degrees. All of those 3 data points go under minute 2. Boy, the time is going faster than I really expected here. I think we're only going to have time for like 1 riddle per data point. What cruel person would sit on a baby? Give up? A babysitter. Okay. Minute 3 of heating. Air is at 59 degrees. I'm on minute 3. Followed up to 59 degrees. Put in my data point with my red pen for air. Soil is now at 32 degrees. 32 degrees for soil, minute 3. And my water is 23 degrees. 23 degrees for water, minute 3. All right. Give me a moment here. I'm going to take a look. Find another rib tickling riddle. You ready for this? What should you do if your ears are ringing? Answer them. Minute 4. Minute 4, the air is already up to 70 degrees. Take minute 4, follow it up to 70. And our soil is now heated up to 37 degrees. Soil, minute 4, 37 degrees. Our water is now at 25 degrees. 25 degrees. Slow and steady for our materials. Okay, for some of them anyway. That reminds me of a riddle. When is a piece of wood like Queen Elizabeth? When the piece of wood is a ruler. Minute 5. Minute 5, the air is continuing to rise. It is now at 77 degrees. Minute 5, 77. Put my cloud. Soil is now 40 degrees. Minute 5, 40 degrees for soil. And our water is now coming in at 27 degrees. 27 degrees for water, minute 5. I think it's time for another rib tickling riddle. What is found in the middle of America and Australia? The letter R. All right, here we are, minute 6 of applying thermal energy to our 3 substances. What is their heat capacity? Air is 79 degrees. Minute 6, 79 degrees for air. Our soil is 42 degrees. Minute 6, 42 degrees for soil. And water is now 29 degrees. Water, minute 6, 29 degrees. Starting to see them level off just a little bit, aren't we? All 3 of them. Oh, here's a classic here. What gets darker as the room becomes lighter? What gets darker when the room becomes lighter? Your shadow. Your shadow. That was actually a pretty good one. Minute 7. Minute 7. We are at air temperature of 80. Minute 7 for soil. We have 46 degrees. 46 degrees. And minute 7 for air, 31 degrees. 31 degrees. That reminds me of another rib-tickling riddle. What do you call a girl who always has change? Give up? Penny. Penny. Now, looking at my phone recording here, I realize these temperatures have gone out of your view site. So in case you are watching, I'm going to lift this a little bit. Apologize if it's, it's still kind of hard to see, I realize, because it's not very well front lit. So I'm going to leave it there for a moment. I'm a little late on my data recording here. Let's get to it. Minute 8, the air is at 81. The land is at 49. And the water is at 32. That was all from minute 8. Closing in on minute 9 here, but I think we have time for another riddle. What's the difference between a December morning and a bad boxer? One is cold out and the other is out cold. All right, minute 9 of heating. We have air at 83. We have soil at 50. And we have water at 33. None of them have leveled off yet, have they? Kind of what we're looking for before we begin the process of cooling, but all 3 of them are still warming up. What do you call an ant who runs off to get married? An antelope. Oh, look, we have time for a second riddle. What do people make that you can't see? It's kind of what I'm making right now. Making noise. All right, heating up. Minute 10. Minute 10. Our air is 82 degrees. Put my little poof of cloud there for air. 82 degrees. The soil is now at 51. And the water is currently heated up to 30, about 34. 34. There we go. Dots, squares, and clouds. All right, let's take one from the biggest riddle book in the world. Here we go. This is perfect for our times. What is yellow and wears a mask? The lone lemon. Oh my gosh. That was terrible. Like the Lone Ranger, the lone lemon. Oh boy. All right. Welcome to minute 11. Minute 11. We are at 82 degrees for air. We are at 52 degrees for land. And we are at 34 degrees for water. All right, so I'm starting to see, I don't know about you, but when I look at my graph, I'm starting to see the temperatures all level off. So they've reached their maximum capacity for taking in heat, for taking in thermal energy. 1, 2, 3 different substances. Air, soil, and water. Now we're going to begin the point right here at minute 11. I'm going to put a little arrow there to remind myself that's where I shut the light bulbs off. Let's get back to business here and get a data point for minute 12. At minute 12, we have 77 degrees for air. Boy, it didn't take long for that to cool off, did it? Land is 52. So that's hanging in there. Water is currently 34 degrees. That hasn't changed at all. So we continue our graph for a cooling stage. And we're going to see how quickly each one of them cool down. What animal is impossible to carry on a conversation with? A goat. They always want to butt in. Get it? You know, goats, they like butt in. They ram you. Yeah. Okay, minute 13 is cooling. Our second minute of cooling. The air is cooled down to 68 degrees. The soil has cooled to 50 degrees, right on the money. And water has not cooled down much at all. 33 degrees. 33 degrees. There you go. You're waiting for another riddle. I know you are. Where can you find roads without cars, forests without trees, and cities without houses? On a map. All right. Before scientists traveled down the Nile River, what was the longest river in the world? The Nile River. Jeez, people. Air. Here we are. Cooling the three substances at minute 14 now. Air is at 55 degrees. The soil is at 46 degrees. And the water is at 31 degrees. If I could use a word that Miss Turner uses in her math class, that would be slope. Check out the slope and see how they're different as the three substances cool down. Quite a bit different. What's the best way to eliminate wrinkles? With an iron. If Bob's father is Ben's son, what relation is Bob to Ben? Ben is Bob's grandfather. Yeah. Now, unless you're in like Kentucky, then you're probably all kinds of things. Fort Point Falls. Here we are, minute 15. We're still cooling. The air has dropped to, I'm going to say 45. The land has cooled to 42. And the water is hanging in there, 29. All three of those were for minute 15. Why do we dress baby girls in pink and baby boys in blue? Because they can't dress themselves. Oh, look at the time. I'm already at minute 16 here. The air, I'm having a hard time seeing it here. The air is at 39 degrees. Land is at 40. Did you notice what just happened? The land and the air just switched places, didn't they? And the water is at 28. 28. Did I say for water during minute 15? Did I say the right thing? I hope I said 29, not 39. Oh, well, I'll clarify it in the iMovie. Ooh, we got just enough time for a riddle. What's the difference between a pear and a pearl? The letter L. What's the difference between a shiny penny and a dirty nickel? 4 cents. Minute 17. Air is 32 degrees. 32 degrees for air. Look at how quickly air is cooling down. The soil is now at 38. 38. And water is at 27. 27. This is good. Really good spending time with you guys. Really like it. Hope you feel the same. Of course, you can always shut my movie off, can't you? Do you know what a good name for a thief is? Rob. Don't you think? Woo, on that note, hey, look at that. Minute 18. This is the end of the line. This is like the last data point. Oh my gosh, where has the time gone? I don't know about you, but okay, I'll stop talking. Let's see. Minute 18, the air temperature is now 28 degrees. 28 degrees. The land temperature is 35. 35, minute 18. And the water temperature is still hanging tough at 26 degrees. 26 degrees. It did cool off a little bit, didn't it? And that's the end of our data story. We're going to connect the dots, so to speak. We're going to take a look at what all this means, and then we'll call it a day. Thanks, everybody.
Welcome back, everybody. Hopefully your graph looks like mine. And we have, wow, 3 substances that really react differently when heated up. Air, look at it. It just gets really, really hot, really, really fast, and then it cools off fast at the tail end of this. Land in the middle. Water takes forever to heat up, and it takes a long time to cool down. The cousin to heat capacity is something called specific heat. It's how much energy it takes to increase a substance 1 degree. Look at water. You know this from experience. It takes forever to boil water. It takes forever for Lake Charlevoix to heat up in the summer. And what that means is it's holding on to that energy and then releasing it throughout the cooler winter months. And this has an effect on our climate called moderation, or moderating our climate, which is to say our climate is not super duper cold and not extremely super duper hot. Take a look at the Grand Tetons out west. I took this picture camping. Its average high is 82 degrees in the summer. The average cold in the winter months, 6 degrees. Very hot, very cold. Mackinac Island, the average high is 76 degrees. The average cold temperature is 11. So we're taking off those extreme ranges here when we live next to a body of water. Taking a look in the lower right, once we've heated up the water, look at how low that slope is. It takes a long time before it's going to give up that thermal energy, whereas air, forget it. It drops it like a rock. And you know how cold the air gets once the sun goes down. My analogy to this is I went on a night dive. There's my buddy Joe. And it was late September. The air was cold, but the water was super duper warm. And the same no matter where you live, whatever body of water. This is Lake Superior. Pick a Great Lake. Pick any lake. And that water will be warm late in the fall. And then if you live next to the ocean, multiply it by like a bazillion. This is La Jolla, north of San Diego in California. My boys were able to go surfing in late December. It was kind of chilly, but it was all right. So hopefully you've enjoyed this lab. I know the jokes were fantastic. Unbelievable. This is Mr. Smith signing off.